So that can't be picked up by any of the technology. Technology can't pick that up. People have to go and have a look, routine inspection. We're going back now to the extruder we looked at right at the start. So this is this Explorer bearing. It's not the exact bearing. This one is a second one. So they're quite big bearings, you can see, in that transfer gearbox, and double row spherical roller, because there's quite a lot of side load on this as well. Out of that, this is off the pinion part, so this is off the part that comes out of the main motor drive, and it's in a certain area where it does get oil fed. There's a splash, a spray bar in there, but it's kind of up there, not down there where it'd be near more oil flow. And this is a type of damage where you're losing material from the surface of the bearing, where that could last days, or it could last hours. It's one of those ones that can go very, very quickly from that to destroying the cage. And once it's destroyed the cage, everything goes sideways. So this was picked up through condition monitoring with acoustic emission detection and then verified with oil sampling. So we used two methods, two condition monitoring methods to pick this up. So this is a bearing from another angle, and what I've done, I've taken one of the rollers out, so you can see this one. There's material being lost on the inner ring. So that's important, and this one is quite important as a find, because this is the first time for me that I'd actually found something with the technology and said, the inner ring on this bearing has something wrong with it, before it was taken out. So when we took it out, retrieved the bearing, could actually prove that the technology gave the right failure. And that was one of the things that the engineering and the operations manager went, wow, we now believe in condition-based maintenance. Of course, this was a very critical asset. This comes from the Made Smarter review a few years ago, and that was a paper that was paid for by the government, I believe, and they looked at all the industries in the UK, so it's UK based, and so they looked at automotive, chemical, pharma, food and beverage, all different sectors, water, utilities, and overall they found there was a part in it that was interesting to me, that 80% of all maintenance is targeted towards reactive events. 4 out of 5 maintenance engineers in any plant are actually working on bringing assets back to life because they've failed. What that means is when you go onto a shift, you know that you're going to go and fix something that day. And I lived that as a maintenance engineer for many years, where I knew at the start of the shift block, I knew the handover was going to be, it's not right, and there's these things to fix. And that means that those assets are controlling us. They're in control. We're not in control. This is a picture of a fryer, by the way, with the hood up. So the thing is with fryers is you can't see the bearings. So you can't condition monitor them in situ because they're sitting in 180-degree oil and they're enclosed. But this fryer was particularly important because we did a lot of work on other fryers to get the bearings changed from normal greasable bearings to a polymer bearing, which actually lasted, actually were fit for purpose. The original, the OEM component wasn't fit for purpose really, because fryers go through caustic boil out once a week, once every 2 weeks, and the caustic gets into everything because that's what it's supposed to do. So that drives all the grease out of all the bearing packs. So I came up with a solution from a US company I found that produced polymer manufactured bearings. So the same bearings as an SKF bearing, but instead of greasing it, the void is filled with a polymer resin. So there is no grease. There's no grease to get washed out. In fact, there's no void for the caustic soda to get into, so therefore the bearings last. So the piece of work we did on this was I got these fitted as an OEM part before it was built and commissioned. That meant that we had no fryer bearing problems. Fryer bearing problems are really, really bad in food, because the first you know about the fryer bearing failing is when it hits the mag detectors in packaging. That's the first you know of it. You hear the mag detectors go off, you'll find some iron filings maybe on the magnets, permanent magnets. Everything gets hold, everything's on shutdown. And everything from the last mag detect, which was probably 3 hours ago, gets pulled back. And that has to go through checks to check that that didn't get contaminated. Everything in the fryer, you have to dump probably 2 tons of oil, which is expensive. It has to be super cool. You have to super cool it because it's hard to get down from 180 degrees. Then you have to clean the fryer out and find any bits that's left in the sump or in the pump. So it can end up being like a whole shift down for a bearing failing in a fryer.